Hello. I'm going to continue talking about the internet layer today. I'll only take a small chunk of it. I want to talk about addressing. The IPv4 addresses will be in this particular video. I'll talk about the other addresses later. Now, the IPv4 addresses did not provide enough addresses. There might have been ways to get around it. People tried. I'm going to show you two of the ways they tried right here. But these were attempts before people decided they just had to go with bigger addresses. The first attempt was called CIDR addressing. To understand CIDR addressing, you have to understand what went before it. Before about 1993, a person or group that wanted to buy IP addresses was very limited in what they could buy. If they wanted or needed a large number of addresses, their only choice was a Class A license, where they bought 16 million IP addresses at one shot. This was done because they were given all the IPv4 addresses that begin with the same leftmost 8 bits. Pardon me. The 24 bits on the right could be anything. So there were 2 to the 24th possibilities there. Also, they required that the first 3 bits be within the range 000 to 011, so they could be quickly recognized. Now, as an example, 53.0.0.0 is one of these classes. I wrote it out there for you. You'll notice that the first 8 bits begin with 001, which is in the range 000 through 011. The user had every single IP that began with 00110101. And most users probably didn't need that, but that's the way it was. Now, if the user could get away with a few less, the next choice down only gave him, oh, pardon me, I want to show you. I put another one in there, and then I put one that is not a Class A license. Because if you look at the top of it, the top 3 bits are 100. Well, Class B may have been a little better. Here you only had to buy 65,000 licenses. That's still a lot of licenses, a lot of possibilities, a lot of IPs. All of the addresses are the same leftmost 16 bits now, with the first 3 bits being 100 or 101. So here's one that fits in there, at least according to my arithmetic, but you all know how reliable that is. So that gave you an intermediate level. It's still pretty high to my taste. Class C licenses were the lowest you could get. You had to buy 256 IP addresses. In this particular case, the top 24 bits were always the same, and you got to fool around with the bottom 8 bits. Now, what would happen is an ISP provider could buy one of these licenses and then farm out the addresses to the people who buy from it. So PC could could buy a certain number of licenses from, say, a Class B ISP. An ISP had bought a Class B group of licenses. The reason why the top so many bits were set was this made it easier for the routers to create tables for packet switching. If they hadn't had this kind of an advantage, it would have been quite difficult. The idea was that the top, say, 24 bits were one group, one network, one autonomous system. So if you wanted to send anything to that group, the router had that whole set of things. There were 256 of them, but only one entry in the table. When something came in and fit in that group, there was one way out. So he didn't. The user didn't have to. The router did not have to have 256 lines in the table. One was enough. And up here for Class Bs, it was even better. Instead of 65,536 lines in the router, you got one. Unfortunately, this 3 sizes fit all didn't work. So the first attempt to try to do something about it was called the classless interdomain routing. That's where we get the CIDR. As far as I know, you're supposed to pronounce it like apple cider. Presume there's an E in there. A user could now purchase a license essentially for any power of 2. This was because the user could specify how many of the leftmost bits were to be fixed. So when the person bought one, we look at what they bought as A.B.C.D/P. Well, A, B, C, and D are like numbers 200 and 0 and 0 and 0 or whatever. They're the 4 numbers we recognize as an IPv4 address. P is called the prefix, and it's how many of the leftmost digits are going to be fixed, aren't going to change in all the IPs that we bought. So, for example, if I say 100.24.62.8/30, that means that the first 24 bits are set, and in the next section, the 6 bits are set, the last of the last 8. That means I only have 2 bits to play with. So if I put 0, 1 in those 2 bits, along with the 8, that'll give me 9. If I put 1, 0 in those last 2 bits, along with the 8, I'll get 10. And if I put 1, 1, I get 1, 0, I get 11, and 1, 1, I get 12. So I only bought 4 IPs, a small number. And it was a first attempt, at least, at trying to break down the groups so people didn't have to buy a ridiculously large number and not use them. All right, well, one way of doing it. I copied this table from Wikipedia. You can go and look at it. What it basically is, and the table doesn't quite fit, so you might want to expand it to the landscape so you can see the whole table. This just shows what the main uses were for some of these. I think I'll expand it for you. So orientation, landscape. So if you only had 1, that was you. If you had 2, they were called point-to-point links. And if you wanted a small LAN, you probably bought with a prefix of 26, 25, 27, 26, 28 maybe. A larger LAN, you went a little higher. A small business where you might have had multiple LANs, you only fixed the first 22. If you were an ISP or a larger business, you'd fix a larger number, a smaller number. If you were a big ISP, you'd go even higher. And that's not quite the last one. I think there's one more. This was the limit. You could only go to 8. So I lied a little when I said you could have any multiple of 2. You couldn't go to above 2 to the 24th. But I don't think most of us would ever have needed to. And that was basically the way it was done. Well, that was one attempt. A second attempt that was made was called network address translation. The idea here was, we don't have enough to cover everybody. But let's take Providence College, for example. We'll give them one IP. They won't have the 1,000 or more that we probably have now. Or maybe, well, it's got to be more than that because we have all the students. It's got to be at least 5,000 or something like that. No, we get one. As far as the world is concerned, if anything's to be sent to PC, it's to go to that one IP address. Now, what happens when it gets there? Internally, when a user wants to get to the internet, it is given a socket. So its address internally is the socket number. In the external world, all of them are the same. But internally, they depend on that they've been assigned. And they don't have to be permanent assignments. They can vary. Well, this works nicely, except for one little thing. How do you know where a server is if you're a client? You know what network you know what IP it's on, but you don't know its socket number. You don't even know the names of the servers or where they are. So to do that, the site's got to have a directory. It's got to advertise to the outside world where its servers are. So when a client wants a particular server, it will send a message to the directory, to the IP address, and ask for the directory. And the directory will send it back what it should send, including the socket number. Now, that seems to be a little more burden, but it's also an advantage. I can hide it. Maybe I don't want somebody using a particular server. Maybe it's sensitive. I want to charge for it or something, so I don't want everybody just using it. So I don't bother publishing it. Only those in the know can use it. Well, those were attempts, but the final line is we had to have a bigger address space. It just had to come. And that's the next video. See you later. Have a good one.